Hello my dear students, this is Akash SD and welcome to the ASJ physics classes. Hope so. You all are doing really great. So students, in this video we are going to solve the questions of satellite when it is revolving around the planet, as you know very well, and when the planet is revolving around the sun, especially the Kepler's laws of motion based question. Okay students, so let's start the video and let's learn the very basic questions. So students, here you can see very well. The NEET 2023 question is, a satellite is orbiting just above the surface of the earth with period t. If d is the density of the earth and g is the universal gravitational constant of gravitation, the quantity 3 pi by GD represents. So students, here the keyword is just above. Okay, so for example, this is my earth here. Okay, and here what is happening, one satellite is there that is revolving here, not near. So this is the what to tell, mass m, radius r, and this is the orbital radius. Just above means what will be there here, you know very well, the orbital radius if r, that means we can write here r equal to r plus h, and what will happen, this h will be very negligible, so hence we can tell here r is approximately capital R, just above. So students, here you have to remember that here in this situation the time period of the satellite is given by 2 pi root r by g in terms of the radius and gravity, and one more formula is there, square root of 3 pi by g rho. Rho is the density, but here this is given d, so we can write here root 3 pi by gd. So students, if you see here from here, that means we can write here, see please, t square is equal to what we can do here, 3 pi by gd. Here what I have done here, both the sides I have just made it here square. So you can see very well 3 pi by gd will represent what? It will represent t square. Okay, if you want to understand this concept, you can click on the I button. Okay students, after that we are going to move for the next question. You can take the screenshot also, no problem. Okay, now next one students, you can see here JEE 2024 question is there. Let's go through the question. A planet takes 200 days to complete one revolution around the sun. Okay, if the distance of the planet from the sun is reduced to 1/4 of the original distance, how many days it will take to complete one revolution? Actually, what is happening in this question? In this question, they are decreasing the distance. So students, here please, for example here, here this is the sun is there, and let's take for example my original orbit is R1 here. Okay, let's take for example, this is how much here, R1, and what is happening, the planet is revolving here, P, R1. Okay, and let's take for example what is given here, this R1 is R. Okay, and the time period how much given here, time period is given here 200 days. Okay, now according to the question what is happening, this period is not period, distance is becoming how much, 1/4 here. So let's take from here P1 to it is coming here in this one here, P2. Okay, so in this situation what is happening, let's take here new orbital radius is becoming how much, 1/4, r by 4, they are asking T2 how much here. So students, here you have to remember that here which orbit is there, here the orbit is the circular orbit. In this situations we know very well, now very basic. In this video I have taken all the basic questions from different concepts. Okay, so t square directly proportional to r cube is there, provided this, the sun should not change. Okay, sun should not change, or later we will see planet should not change when the satellite is revolving around the planet. So in this situation we can write here, see please, this t2 by t1 whole square is equal to r2 by r1 whole cube. Okay, r2 how much given here, r by 4, r1 how much given here, r. Okay, so we can write here, students, see please, r by 4 by r cube. So anyhow r cancel, it will become what here, it will become here 1 by 64. Okay, hence we can write here, see please, this t2 by t1 is equal to square root of 1 by 64, and that will become here how much, 1 by 8. So we can tell here this t2 will become here t1 by 8. T1 how much given here, 200. So we can write here 200 by 8. So 200 by 8 how much here, students, here 25 days in the same unit. So which option is correct here? The correct answer is here option A is the answer. Okay students, great. Next one, let's see. JEE 2024 question again, and very standard question. Here you are going to understand very beautiful concept. Okay, so see here students, here a light planet is revolving around a massive star in a circular orbit of radius r with a period of revolution t. If the force of attraction between planet and star is proportional to r to the power minus 3 by 2, then choose the correct option, and here options are there. So students, remember that here previously we have learned what I have taught you. I have taught you this one here. T square is directly proportional to, okay, small r, orbital radius, or capital R orbital radius. So this is valid if you know na, gravitation force, it follows inverse square law. So this is only valid if F is inversely proportional to r square. In this situation, only this formula is valid. But after that, here you can see very well, this is not r square, r something is given, okay. So students, let's check here. Here it is given, no? Force is given. The force. So here, let's see here, please. I am writing here F inversely proportional to r to the power 3 by 2. Okay. But I will solve for the very general cases there, no? Let's take, for example, let F is inversely proportional to r to the power n. Okay. Now, students, what will happen that here? We are going to find out the value of, the cases are there now, but we are going to find out in terms of n relation between t and r. Okay. So let's take, for example, here, students, here what is there? Planet is there, and here what is there? Massive star is there. Okay. So here what will happen that here one gravitational force will be there, Fg, and this one will only act as which one? Centripetal force. This gravitational force will act as centripetal force here. Okay. So as, see please, as this, students, this gravitational force is acting as a centripetal force here. Now this is a gravitational force. So gravitational force formula, you know very well here, na? G mm by r square, but here I will write here this one here, see. G, okay, m by, here I am writing here r to the power n. Capital is given, so let's take here capital, no problem here. R to the power n, and this orbital radius also capital R according to the question, no problem. R to the power n is equal to centripetal force formula, see please, mr omega square. Okay. After that, students, let's see here. Now, just simplify this, it will become here omega square is equal to, see from here, both the sides m and m is cancelled, so it will become here gm by r to the power, this r will go this side, so it will become here r to the power n plus 1. Okay. Or we can tell here omega square proportional to r to the power n plus 1. Okay. Now, students, after that we have to go to the time period again. Okay, again. Time period formula, you know, t equal to 2 pi by omega. So t square how much? It will become here 4 pi square by omega square. That means we can write here t square directly proportional to 1 by omega square. Okay, 1 by omega square. And what you know, omega square is inversely proportional to r to the power n plus 1. So when you will use this one and this one, what it will come? T square directly proportional to r to the power n plus 1. Please remember it very well. See here, please, here value of n how much in this situation? In this situation, value of n is 2. So it will become t square directly proportional to r to the power 2 plus 1, 3. But here the value of n how much here? This value of n is how much here? 3 by 2. So it will become here, students, just put the value here. Now just put the value here, see, t square directly proportional to r to the power 3 by 2 plus 1. So 3 by 2 plus 1, how much? 5 by 2. That means which option is correct here? The correct answer is your option here, t square directly proportional to r to the power 5 by 2. Okay. And remember this very well. Okay. Capital R we are writing, but here orbital radius. Okay. Small r equal to r plus h. General way. Okay. Next one, students, let's hear please. JEE 2023 question is coming for you, and the question is here, see, the orbital angular momentum of a satellite is L when it is revolving in a circular orbit at height h from Earth's surface. Okay, now if the distance of satellite from the Earth center is increased by 8 times to its initial value, then the new angular momentum how much is there? Okay, so again, just let me see here, please, here. Now this satellite is there, and here planet will be there. Okay, and let's take here. Now this is R, and it is revolving at how much height? H height is there. Let's take like this here. Revolving where? Revolving at the height of h here. Here satellite is revolving, not here. Satellite is not here. Okay, just let me remove this. Not here. Okay, students, good. So after that, what we are going to see now? In this situation, satellite is here. So you know, students, what is the formula here? You know angular momentum formula, students. We know that as L equal to, generally I am writing here, L equal to mv into r. What is r? This r is the orbital radius, and as I have told you, r equal to capital R plus h. Okay, so here L equal to mvr. Now let's put the values, please. L equal to m, orbital speed v. Formula, you should remember the formula here. What is the formula, students? See, please. Root gm by r and into r. So when you will simplify this here, r by root r. So this L will be directly proportional to root r. Okay. Now students, after this, what is happening that here? See, first one, what is happening? At a height of h, how much orbital radius? Let's take orbital radius is r. And what is happening? This orbital radius is increased. In the question, what they are telling? The orbital radius is increased by how much? Increased by 8 times. So it will become here how much? R plus 8r. That means how much coming here? 9r. This one is r1 is r, r2 is 9r. This one we have got. Now students, after that, from here, what we can tell? I can tell you, see please, L dash, or okay, L2 by L1. No? L2 by L1. No, this is not there. So L2 by L1. What we can write here? See please. R2 by R1 square root from here. Okay. So now R2 how much? Anyhow 9R. R1 is R. R cancel. Root 9 means 3. So what this is coming here? See please. L2 equal to 3L1. And initial is given L. So we can write here how much coming? L2 equal to 3L. Kindly remember this one. L is directly proportional to root r. Okay, students, so which option is correct here? The correct answer is your option B is the answer. See how much beautiful way we are solving the question. Okay, next one, students, let's see please. Next one, see. Two satellites A and B having masses in the ratio 4:3 are revolving in a circular orbit of radii 3 and 4 are respectively around the earth. The ratio of total mechanical energy of A to B is how much here? Okay, students. So let's see here, students, here mass ratio for the satellite, how much given here? MA and MB. MA is to MB. Mass, how much given here? The mass ratio 4/3. 4:3, or you can write MA by MB equal to 4/3, no problem. Okay. After that, next one, what is given here? Having the orbital radius of 3r by 4r. So we can write here RA is to RB is equal to how much? 3r by 4r. Both will simplify. RR will cancel. So 3:4. So you can see very well, students, here. See from here. This is the RA. Now satellite is here. Okay. Small 3. And next one, let's take this is the RB. Okay. And here is the B. Okay. And anyhow, this is the satellite. So here what is present here? Planet is there. Okay. Some planet is there. Okay. At the center. So students, for this you should know the formula of the energy. Energy formula. Have to remember that. E equal to minus G M by 2R. Now this is the energy formula. Check out this here. Huh? Correct only. Okay. So here what will happen that here in this situation, students, anyhow the planet is same only for both the orbits. So we can tell here E is directly proportional to M by R. Okay. Now after that here in the students, they are asking from where to where? A to B. Hence EA by EB is equal to, very easy now. See please, MA by MB into inversely proportional RB by RA. Okay, MA by MB how much from here? See please, 4/3. 4/3 into RB by RA from here, just reverse. So how much coming here? 4/3. Simplify this, how much coming here? 16/9. Which option is correct, students? Just see the options very well. Which option is correct? The correct answer is your option B is the answer. Okay, great. Next one, let's see, students. NEET 2024 question based upon the energy concept only. Okay, so see please. The minimum energy required to launch a satellite of mass m from the surface of Earth of mass capital M and radius r in a circular orbit at an altitude of 2r from the surface of Earth is how much? Okay, students. So first let me draw here, please. This is the Earth. Mass of the Earth how much given? M. And radius how much? This radius is r. Okay, now what is happening that we have to launch a satellite so that it should go where? Like this here. Okay, little bit. Now, and altitude how much here? This altitude is how much here? 2r. So can you see very well from the center how much distance is there? From the center, this distance here. You know this is r, this is 2r, so this distance how much here? 3r. Okay, students. So now let's take for example here. First, let's take satellite is here. Okay, this is the initial situation, and after that when it will come to the orbit, this is the final situation here. So in this situation what we have to do, we have to conserve the energy. Okay, students. So let's see here please. According to conservation of energy, what I am using? Conservation of energy. So what this will become here? See please. Energy initial point and energy final point should be same. Okay, because we have to calculate. We have to calculate what? In the question we have to calculate how much energy is needed, actually the kinetic energy how much needed. Okay, so see please here, ui plus ki is equal to, okay, anyhow final. Okay, so ui how much here? At the surface of the earth, formula minus g m by r plus this much energy is needed. And what is the final energy formula, students? I have told before also. See here please, how much there? Minus g by 2r. So see here please, again minus g by 2. Small r value how much here? This one is the only small r here, no orbital radius. So this will become here 3r. Okay, so hence students we can write here this ki is equal to how much coming here? See please, minus g by 6r plus this will go that side, g by r. Okay, after students when we'll simplify this, what this will come here? It will come here g by r, and it will come minus 1 by 6 plus 1. So it will come how much here? 5 by 6. Which option is correct here? Just check out please here, students. The correct option is here. How much? R is missing. See here R is missing. There. So option A is the correct answer. Is it? Minus g by 6r. Okay, great. Next one, let's see. Now the Kepler's law based questions are coming. Now, if you have seen my previous video, you will understand all the things very well. Okay, so let's see here the question. J2020 question is here. See please. A satellite in an elliptical orbit around a planet P. It is observed that the velocity of satellite when it is farthest from the planet is 6 times less than that when it is closest to the planet. The ratio of distances between the satellite and the planet at closest and farthest point is how much here? So this is what is happening the case. The satellite is revolving around the planet. So in an elliptical orbit, what happens? That students here please. The planet will be here and the satellite will be revolving here. The satellite will be revolving here. The satellite is revolving. So students, remember that one thing here in this situation. See here please. At this point, what will be there? The satellite will be close to the planet. This is called which distance? Very close means perihelion. What this is called here, students? Perihelion. And let's take here speed how much here? Vp. And this speed is used to be the maximum. Okay. And this one I am writing here rp. Okay. This distance rp. In previous video I have covered all these things. Now what will happen that here? When this satellite is here, now revolving like this. So at this point what will happen? Away, that is called aphelion. And here what used to be there? This speed is used to be the minimum. And this distance is used to be how much here? This distance is used to be RA. Okay, students. So again, in the question, what they are telling? Let's see the question again. When it is farthest from the planet, 6 times less than when it is closest to the sun. So what is happening that here? Speed at point A, anyhow minimum, is how much? 6 times less. That means it will come in how much here? Vp by 6. Va is how much? Vp by 6 here. Okay, and as from the Kepler's second law of motion, we know very well, angular momentum will be conserved, mvr will be conserved, m is constant, so v into r will be what? Is constant. So we can write here, see here students, va into ra is equal to vp into rp. Which distances they are asking? Closest to the farthest. Closest is where? Rp is the closest here. So what we can write here, see, rp by ra is equal to rp by ra, how much here? Va by vp. Va by Vp. So Va by Vp from here, what this will come? Va by Vp from here, how much it will come here? It will come here 1 by 6. So which option is correct here, students? Just check out here. The correct answer is here. Option A is the answer. Okay, students? Great. Next one, second last question. Here we are going to learn the lot of basics actually. Now, basics already we have learned, but more things are there. See please. NEET 2018 question. The kinetic energies of a planet in an elliptical orbit about the sun at position A, B and C are Ka, Kb and Kc respectively. Now, after that, see here, AC is the major axis, see the diagram, and SB is perpendicular to AC. This SB is perpendicular to AC at the position of sun as shown in figure. Then, what is the things are there? So, students, as I have told you very well, what I have told you here, students, see please here, this is the closest distance, RA. So, what is there? Here, distance is minimum. That means here what will happen? This is called which distance? Anyhow, which point? Perihelion. And here what will happen that here? See please here, this speed perihelion, no? RP. This VP will be what? This will be maximum. That means kinetic energy Ka will be also maximum. Speed maximum, kinetic energy is also maximum if revolving like this. Okay. Now after that here, when it has reached here, anyhow this distance is what? Aphelion, away. Now as I have told you very well. And here what is there? This Va will be minimum. So what about the kinetic energy? Speed is minimum. That means kinetic energy is also minimum. Kc minimum. Okay. So what is happening that here? Here kinetic energy maximum. Here kinetic energy minimum. Somewhere in middle. Here what will be there? Less than maximum and more than minimum. So just check out the option please here. What is the correct option here? This you can see here. Ka is the maximum, Kc is the minimum, Kb in the middle. So correct answer here option B. Okay. And with this question I will tell you one more basic concept. Sometimes they will ask work done by the gravity, because what will happen that here? Let's take for example here. For example, if the planet is here. Okay. So here one force will act here. Now this Fg. So what will happen that here if they are asking work done by the gravity? So remember that here students, see please. Work done by the gravity when it is moving from where to where? When it is moving from students where to where? This perihelion to aphelion. So from the work energy theorem here, what is happening to the kinetic energy? This kinetic energy is decreasing. That means this work done will be negative. If they ask work done by the gravity, this is where to where? This is perihelion to aphelion. If they ask aphelion to perihelion, where to where? Aphelion, this aphelion to the perihelion. Here what is happening that here? The kinetic energy is the increasing minimum to maximum. That means here it will be how much here? Positive. Okay. When the kinetic energy is increasing, positive work done. When the kinetic energy is decreasing, negative work done. Okay. Please remember that this basics they will ask in exam directly. Okay students, great. Now we came to the last question. Last question. NEET 2009 question. Very basic, see please. The figure shows elliptical orbit of a planet M about the sun S. The shaded area SCD is twice the shaded area SAB. Okay. So SCD and SAB given. If T1 is the time for the planet to move from C to D, this is the time T1. Okay. And T2 is the time to move from A to B. This is T2. Then which option is correct here? Okay students. So here T1, now let's take here this area I have taken A1. And here this area I have taken A2. So according to the question, you can see that here area SCD is twice the shaded area SAB. So we can write here students, according to the question, what is given? A1 is equal to 2A2. Now question itself is telling that. Now we know that as from the Kepler's second law of motion, what will be constant? Areal velocity will be constant. That means area per unit time will be constant. We can write here A by T constant. That means A1 by T1 is equal to A2 by T2. Now students, here there T1, T2 is coming. So if I write here for example T1 by T2. T1 by T2, what this will come here students here? See please, A1 by A2. Now A1 how much given? 2A2. 2A2 by A2. So what is happening? A2 cancel. That means we have got here students this one. T1 by T2 is equal to how much? 2. That means correct answer is here. The correct answer is here. Option B is the answer.